So for this video, I want to go through solving parametric equations or graphing parametric equations. This one asks us to convert the following parametric equation into a rectangular one and then sketch the graph. So what we're going to do, we have these two equations, both involving t. So parametric equations are graphed in the xy plane, but in terms of the variable time t. And then once we plug in t values, that gives us these ordered pairs x, y. So what we want to do is to rewrite this in a way where we only have x's and y's, so we're dealing with some kind of rectangular equation that we can graph. So the first thing that we want to do is to eliminate the parameter. T is our parameter time, and we want to eliminate that. So what we're going to do is try to isolate t in both of these equations, and then we could substitute and get rid of it. So what we're going to do is in each of these, solve for t as much as we can. So I'm going to add 1 to both sides here, and then I'm going to divide by -2. Leave that -2 on the bottom alone. We'll take care of it in a little bit. So I have cosine t. And then in this one, I'm going to do something similar, but I'm going to isolate sine t. Okay. So we have isolated sine and cosine, and one thing to keep in mind here is that we know this thing called the Pythagorean identity, which says that cosine squared t plus sine squared t equals 1. Well, let's use that. If I square both sides here, if I square both sides, then I can add these things together, right? So 1 is equal to cosine squared t plus sine squared t, and then I can substitute. So that's 1 is going to equal, and I'll put that square on the top and the bottom now. So all I have done here is put these in where they go, because cosine squared and sine squared are equal to those two things. And I went ahead and distributed that square to the top and bottom of the fraction. Does this look familiar? This is a standard equation for an ellipse. So we can do this. We're going to graph. So that's the directions here, or sketch the graph and be sure to indicate direction. Okay, so our graph will be an ellipse with center HK. In this case, that will be -1, 3. A is 4, B is, A is 2, sorry. A squared is 4. A is 2, B is 4, and C would be then, C squared would be B squared minus A squared. So 16 minus 4, which is 12. So C is √12, which is 3 and some. Okay, so what we want to do then, let me do this in a different color. What we want to do then is to sketch the graph. We are going to sketch the rectangular graph with dotted lines, a dashed ellipse. So the center is -1, +3. A is 2. B is 3, 4. 1, 2, 3, 4. So connect that, but with dotted lines. And then we're going to put the foci on there. So 3 and change away. Okay, so now we need to go back to the fact that this is parametric. Be sure to indicate direction, and t is only going from 0 to pi. So what we're going to do is make a chart. So t, I don't know how you guys do this. I'm going to do it like this. Put my t's up top, and then my x values and my y values. So let's do this in blue. So when t is 0, x is going to be -1 minus 2 cosine of 0. Plug in t equals 0. So we get -1 minus 2 times the cosine of 0, which is 1. So -1 minus 2 is -3. Do the same thing for pi over 2. Cosine pi over 2 is 0, so that would be -1. And then do the same thing for pi. -1 minus 2 cosine of pi. That's -1 minus 2 times a -1. So -1 plus 2, which is 1. And then we're going to do the same thing with our y values, plugging back into what you started with. So y is equal to 3 minus 4 sine t. Plug in t equals 0. So y equals 3 minus 4 times the sine of 0, which the sine of 0 is 0. So we get 4 times 0, so y equals 3. When t equals pi over 2, we get y equals 3 minus the sine of pi over 2. Sine of pi over 2 is 1. So 4 times sine of pi over 2, sorry. So that would be a 4. So that'd be a -1. And then pi. Okay, so maybe I should have talked about this already. Why I chose 0, pi over 2, and pi. I chose the beginning of our interval and the end of our interval, and then something that was halfway through. And that's a good thing to do. So when we do this, when we plug in pi, we have y equals 3 minus 4 times the sine of pi. The sine of pi is 0, so 3 minus 0, which is 3. So this will be our first ordered pair, our second, and our third. So the first ordered pair is -3, 3. That would be this guy, so that's 1. The second ordered pair is -1, 1. That's 2. And the third ordered pair is 1, 3. That's this guy right here. So we are going to fill that part in and put the direction on it. So go 1, 2, 3. So the arrows will go that way. It makes sense that we will only get half of the ellipse here because our interval is from 0 to pi, not 0 to 2 pi. So we're only going to get half of a rotation. The important thing is where it starts and it ends. If I were to plug in only 0 and pi, I would only have these 2 points. I wouldn't know which way I went around the ellipse to get there. So that's why you plug in the point in the middle as well. So that is how you convert to a rectangular equation. That is this part. Here's your rectangular equation. Then sketch the graph. So sketch the full ellipse with dots, with a dashed line, and then fill in the parts that you want using a table, and make sure to put direction on your graph. If you have any questions, let me know.